All right, folks, Mr. Fortin back here with a second video, which again is going over a few of the proofs that were in the homework for section 3.7 day 2. In the first video, I went through kind of the way that all the proofs are structured, okay? So basic idea of section 3.7, which was using more than one pair of congruent triangles is, well, sit down to do a proof, find one pair of triangles that are very easy to prove are congruent, okay? I call those in the last video the helper triangles, okay? Use those helper triangles. Once you get them proven congruent, you can use Cpctc to get angles, sides, right? Anything else to prove congruent in those two original congruent triangles that might be in two other triangles that you could also prove are congruent. So think about it. If I can prove one pair of triangles congruent, then I can take these sides that are in both of these triangles, and they're in these other triangles here. And if I know that those sides are congruent, then maybe I have enough information to prove that those other pairs of triangles are congruent, okay? And then, right, once you get that second, harder to find pair of triangles congruent because you had to do the original ones, you can use Cpctc again to perhaps prove what it was you were asked to prove here, okay? So as a reminder, what I call this section is double Cpctc, because if Cpctc is not shown up in your proof more than once, you probably didn't do enough, because as soon as you get triangles proven congruent through SAS, SSS, ASA, HL, SAA, then you use Cpctc to get some of the particular parts, be it a pair of angles or a pair of sides. Corresponding parts of congruent triangles are congruent. All right, so let's take a look at this one. Let's do this one as an example. This stumped a few folks here, and let me zoom in a little bit here so we can see a little bit more clearly. Oh, computer's being slow. I don't want to print. No, I don't want to print. All right, let's check this one out here. All right, so we're given triangle. Oh, we're giving congruent triangles. I know what I'm going to say first. If you watch the first video, you're going to know why. Because we have helper triangles, right? We have some helper triangles here. So my statement, number one, I want to get that helper triangle into my proof. Statements, reasons. Step one, triangle LMN, congruent to triangle RST. And that's a given premise. Okay, these are called your given premises. That's called your given diagram, right? Your given diagram. Your given premises, given diagram, and you have a proof statement, okay? You're copying all this down, right? Don't get started on proof until you copied it all down. I already have it here, so I'm gonna keep going. Copy it all down because now I have congruent triangles and we have altitudes I can write down. I have some right angles to work with here, okay? So that's nice because perhaps those right angles are gonna help me prove some triangles are congruent because I have an angle in, for instance, LXN. RYT, I know that I have an angle, corresponding angles are congruent. So here you might go back to like the list of reasons why triangles are congruent. We have SSS, SAS, these are called the triangle congruency shortcuts, SSS, SAS, ASA, HL, and SAA, okay? So HL is looking like a potential customer here. Like we potentially do HL because we have some right triangles. Remember, HL means hypotenuse leg, right? Hypotenuse leg. So if we can get LN and RT congruent to one another, and just one of these other legs here, perfect. We got the whole thing proven. We're good to go. So let's maybe take a look at this here and see perhaps it's HL, maybe it's something else here. All right, what are some triangles I can prove are congruent right away? Ooh, this is tricky. What do I do here? Well, we're given the triangles congruent right away, so we're probably going to use that, okay? Ultimately, I think we either need to get this triangle congruent to this triangle, or we can get potentially these large triangles congruent to one another. So if I outlined this, if I'm trying to think about this, if I got that triangle congruent to that triangle, that would be a great thing because ultimately we're trying to prove LX and L and RY are congruent, right? This is what we're trying to prove. Is that LX and RY, are they congruent to one another? Are they congruent? And if we know that this thing in purple here is congruent to that other thing in purple, then through Cpctc, those two things would be congruent to one another, okay? So I'm going a little bit ahead of things here because you're looking at the end. That's what I need to get to. And then you're looking at the beginning. What can I say to get there, right? I got to say that these two triangles are congruent. So let's try to get that there. So, but you're given this. You're given that LMN, and this is why I draw it out, because you got to spend time with this. You got to get into it. You got to be visual. You got to be looking through it. Because I think something it occurs to you, this puzzle. Solving a puzzle is so much fun. I like it so much here. So if you think back to that purple triangle, earlier, purple triangle earlier, and this green triangle. You know these two green triangles are congruent to one another. This is triangle LMNs right here. Triangle RST, that's right there, okay? Look, corresponding parts right here. These are perfect. I'm ticking those. Why? Why is LN and RT going to help us prove this thing here? Because those are both sides on this second prover triangle that we're going to prove. And look, wait a second. If I say that and that, that's pretty nice too. I could say that and that because look at this here. I have an angle, angle side at this point. Angle, angle side. Okay, so this is going to be HL. This is going to be this one. It's going to be angle, angle side, or SAA. All right, let's break it down. Perhaps you don't see it. Perhaps you want to go a little more slowly with me here. But the idea of this is we are going to use Cpctc. Well, I know I want to get that triangle congruent to that triangle. And I know this is true already because those are two triangles congruent. So I'm going to say Cpctc. I'm going to get Ln, oops, not Lm, Ln equaling, that means distance Ln equals distance RT, and that's through Cpctc. And I'm also going to get angle N congruent to angle T, and that's also through Cpctc. So if I know this and I know that, then, right, I have to get the, because look at this, these are freaking congruent triangles there. They're giving us congruent triangles. And these are corresponding parts of congruent triangles. Corresponding parts of congruent triangles, what do we know about them? They have to be congruent as well. Stay awake, stay really awake here. You got this, okay? So if we have that, if we know that, these are two parts of our prover triangles. The ones we ultimately want to prove are congruent, which is triangle RYT and LXN. And the reason why we want to prove them are congruent is because, again, we want to get LX and RY congruent to one another, which are corresponding parts of these triangles we're hoping to prove are congruent. So the way we can do that, we've said we have a segment, we have an angle. Do we have another angle? Yeah, we do. We got to put that to work for us here. The fact that these are altitudes, and I'll introduce that as the given premise. I haven't talked about that yet. Segment LX and segment RY are altitudes. Oops, altitudes. I think I spelled that right. And that's a given premise. And what do we know about altitudes? What are they defined as? They're the segments drawn from a vertex of a triangle perpendicular to the side opposite, right? To the line containing the opposite side here. So those are altitudes. So definition of altitude is going to give us the perpendicularness of this one here. So I'm going to know that LX is perpendicular to XN. And I'm also going to know that RY is perpendicular to YT. And that's definition of altitude. Okay, definition of altitude. It means a segment that's perpendicular to the side opposite that vertex where the altitude is drawn from. It's wordy. There's so much words and numbers in geometry. Okay, so now we know those are perpendicular. So then we can say this, that measure of angle X equals 90, which equals measure of angle Y. Okay, and the reason why I know that is, well, I knew that these were perpendicular lines, and the definition of perpendicular lines is that they're two angles that are right angles, okay? But I'm not saying that they're right angles, I'm saying they're 90 degrees. So I need to use the definition of right angle, because a right angle is an angle that measures 90 degrees. So here, these are two reasons. Perpendicular lines, definition of perpendicular, there are two lines that form right angles. Definition of right angle are angles that are 90 degrees. They're each 90 degrees. So this proves that we have another angle congruent to another angle. So here we have S, A, S, A, and then finally A. Those two angles are congruent to one another because they're both 90-degree angles. They're both right angles because those two lines were perpendicular to us because it was given to us that it was an altitude, okay? A string of reasoning, just getting it down to those two angles being congruent to one another. So this is AAS, and that's what I'm going to put next. I'm going to put that triangle LXA is congruent to triangle RYA, and that's through SAA. And then step 7, so this is kind of a decently long proof. Oh, the whole thing, right? What was I doing? Let's go back to the original list. One pair of triangles congruent, the helper triangle, they gave that to us. We used Cpctc to help us get that prover triangle, the second pairs of triangles were congruent to one another. Now I'm just going to use Cpctc again to hopefully prove whatever it was I was asked to prove. And yes, Lx and Ry are parts of these purple triangles that we just proved are congruent. Look, we see that right here. Lx and Ry are certainly corresponding parts of congruent triangles. So we're going to get Lx congruent to Ry. And reason for that, Cpctc. Drop the mic, another video down for you here. Okay, so maybe watch that video, rewatch it, redo it again. Do you have to be perfect at this kind of stuff? No, but like you want to push yourselves, you want to get better, and ideally be able to break something down like that, solve a puzzle on your own with some practice, and with asking questions, with coming to office hours. And I think a few of you guys can get there. All right, thank you for watching this video. I got one more coming for you, number 20.